IB Pass Paper, November 2011, High Level Paper 2. Hypochlorous acid is an example of a weak acid. State the expression for the ionic product constant of water. So the first question has nothing to do with hypochlorous acid, it's just asking us for the value for kW, the ionic product constant, is equal to the hydrogen ion concentration times the OH minus ion concentration. That's our expression. Then we're told that a household bleach contains sodium hypochlorite at a concentration of 0.705, and the hypochlorite ion is a weak base. There the hypochlorite ion is acting as a weak base. It's picking up a proton from water and it's making the conjugate acid, which is the hypochlorous acid, and at the same time OH minus ions. We're told the pKa value of hypochlorous acid is 7.52, so we're asked to determine the Kb value of its conjugate base. Well, there's several ways we can do this, but we need the expression, the Kw expression. If we take the fact that Kw is 1 times 10 to the minus 14, this gives us a value for pKw equals pKa plus pKb. It's the acid dissociation constant plus the dissociation constant of the conjugate base. And we know that pKw is equal to 14. So for our calculation here, if the conjugate acid HOCl is 7.54, we can say that there we are, pKa 7.52 plus pKb equals 14, and so you can see pretty much there that pKb equals 14 minus 7.52 equals 6.48. I don't know what's happened to the formatting there. Let's just give that the colour. Now to determine, oh sorry, I'm not quite there yet. We're asked to work out the Kb value, not the pKb. Well, Kb, the relationship between pKb and Kb, pKb is the negative log, so Kb is equal to 10 to the power of minus 6.48. This is effectively what we're looking at, is the anti-log here, and this comes to, working in the calculator, 3.31 times 10 to the minus 7. Our value for Kb. Now we're asked to determine the concentration of OH minus in moles per litre at equilibrium and state one assumption made in arriving at your answer, other than a temperature of 298. Alright, so we're looking at this equation. We've now got the pKb value for this equation, so the Kb value. So we could say that Kb equals, and we can see the two species, the concentration of HOCl and the concentration of OH minus, and this is divided by concentration of OCl minus. What's happened to that? We've missed the capital OCl minus. Now we've ignored the water, of course, in this equilibrium, because water is in vast excess and isn't used in the Kb expression. Now, if OCl minus is a very weak base, it means that effectively very little of the equilibrium lies to the right hand side, and so we can take the value for the hypochlorite ion as being the initial value. Now we're told the initial value is here 0.0705, so this is our assumption. We're going to rearrange our equation to get, so Kb down here, Kb multiplied by the OCl minus ion concentration, which is going to be the initial 0.705, is equal to HOCl multiplied by OH minus. Now, as these are both the same number of moles, obviously in our equation, 1 mole of that changes to 1 mole of that plus 1 mole of that. X moles of the OCl minus changes to X and X of that. So the hypochlorous acid and the OH minus ion concentration must be the same. So this gives us the OH minus ion concentration squared. As they're both the same, it's the same as writing OH minus ion concentration squared. Now, to get an expression for Kb, we know the value of Kb is 3.31 times 10 to the minus 7. Let's put that in here, 3.31 times 10 to the minus 7. And we're going to multiply this by 0.705, and this is going to be equal to h plus squared. So the square root of all of this is going to equal h plus squared. Oh, sorry, OH minus squared. OH minus not squared. The OH minus ion concentration. So now we need our calculator. To 3.31 times 10 to the minus 7. 3.31 exponential minus 7 multiplied by 0.705. That comes to 2.33 times 10 to the minus 7. Is it? 1, 2, 3, 4, 5, 6. Yes. Now we take the square root of that, and that comes to 0.000483. Better expressed as 4.83 times 10 to the minus 4. Moles per litre, of course. Now, finally, we have to calculate the pH of the bleach. Well, from this OH minus ion concentration, we can get the pOH is equal to the negative log of the OH minus ion concentration. So it's the negative log of we take our log, and that gives us minus 3.316. So the pH is 3.316. And we know that pOH plus pH equals 14. Hence pH equals 14 minus 3.316, which comes to 10.7, 10.68, 10.7. And that's the end of this question.